Hi
Next up, we're
everyone.
delving back into the world of technology and technical implementation with our next speaker, Nazar Hussain. Nazar has been in the software development industry for over 15 years. He's worked at Lisk and he's been a senior architect leading 3 products for eCommerce. But he's been working on blockchain development of late, which has become one of his passions, and he's going to help us figure out how to build a blockchain application in JavaScript. So thank you, Nazar.
Thanks for having me here. And hi everyone, it's Nazar here. And today we will be talking about Lisk and Lisk SDK and how can we build a blockchain application. My name is Nazar, as Steve told. I've been working with the Lisk for over 3 years now. And if you want to find out more about me, you can check on my LinkedIn profile. And so here is the today's agenda we have. So first thing we will talk about what is Lisk, and then we will talk some of the points that why Lisk is so important in this ecosystem of the blockchains and why we recommend you guys to use the Lisk. And then afterwards we will go through some of the timelines and see how can we relate the new features that we are going to release with the timeline. And then afterwards the most important topic of the today session is the Lisk architecture that we designed, which is flexible, integratable, and open, that can help you build any blockchain application, whichever you want. And then at the end of the session, we will go through a hands-on demo where we will together build the blockchain application using simple JavaScript. And if you have any question, I will take those questions at the end of the session. I request everyone to be focused to the questions only related to the technology aspect of the blockchain, and more importantly, only focus to the content of today's session. And if you have any extra question, we can take them over to other channels afterwards. And let's start with today. And here we have our first topic that we introduce you to the Lisk SDK. And Lisk motto is that Lisk has set itself as a blockchain technology accessible to make the blockchain technology accessible to everyone. That's our goal, and that's what we are working for the last 3 years. And we have seen different blockchain aspects, and yeah, it's a complicated technology, and we decided that we need to build it in a way that it becomes accessible for everyone, so anyone can use in the future. And if you ask a question, many of you have heard about us, but about the Lisk. These are the 4 points that can cover the whole ecosystem that we are building so far. That we have a decentralized network that is running over 3 years now successfully, and we are building a blockchain SDK that is purely in the JavaScript that can help you to build any kind of a blockchain. And then we can, the Lisk is itself a blockchain application platform where you can build multiple blockchain applications all together, and you can also link them together, that we will cover afterwards. And then Lisk itself is a token, LSK, and this LSK token is been live and have a very huge value on the token market. You can check it online with further details. And on with that, I can share with you some overview what the Lisk itself is. We are in the blockchain industry since 3 years. We are technically a delegated proof of stake consensus algorithm. So don't mix up with the proof of work. And we are a team of 30 plus employees working as a light curve team and building for the Lisk. And we are the first on CryptoMesto for GitHub activities for the last 6 months. And we have different community center in Utrecht, Tokyo, and Berlin. And you should not forget that we have an opening event for the Lisk Center Berlin on 20th of November 2020, and it will be an online event. I request everyone to join us there, and we will share more details of the Lisk Center and the activities we are going to perform there. Our mainnet is optional, operational since 2016, and so far we don't have any kind of attack or any problems running that mainnet. And now we go to the major point, that why you guys gather here and why you guys should be interested in using the Lisk. So first of all, Lisk is a research-driven product. It is not something you can say technically adventure. It is based on some research. We have a proven research. We have a team of 5 full-time scientists which are working on providing the base research, on top of which we are building this technical solution. So anything you will see, any feature you will see in the Lisk, you can relate or find out the particular research pattern or research papers that we have published against it, which we call them LIPs. And then the Lisk is itself a developer-focused product. It is not built for some kind of a technical corporate sector. It is built totally focusing the developers' need and totally focusing the developers. And it's accessible because it's been totally built in the JavaScript, and JavaScript is the most accessible technology around here, and it's been known to everyone. So anyone who knows a simple JavaScript can build a blockchain application using the Lisk SDK. And Lisk is a flexible, provide you the flexible architecture, which we will explore later, which can help you to build different use cases because of the flexibility it provides. And then we are a scalable solution. You can build side chains with us, and that side chains can grow independently, and they don't have any kind of problem related to the exponential growth or dependency on the mainnet. And with that said, is our timeline. We were started in our inception. Our idea was started in 2016. We launched our testnet, and we had our ICO in 2016 as well. And with that said, we launched our first Alpha SDK, which was version 2.1.0. It was in July 2019. And after July 2019, we had been working very hard on a lot of other stuff. And some of those features I can highlight you guys. And if you have any questions related to those features, you can post me afterwards in the session. So Lisk 2.0 was an alpha SDK, and afterwards we have the Lisk 3.0, and these are the highlights for it. We introduced a Byzantine fault tolerant consensus protocol in Lisk 3.0. We also introduced a pair selection and banning mechanism, and we also have covered the problem or attack which was possible to replay the transaction in a different chains. So we have fixed these things, and like to be highlighted, these are just the highlights. These are not all feature set that was introduced in 3.0. And afterwards, we have the Lisk SDK 5.4.0 highlights. We introduced a lot of new features. The most important one is that we introduced the dynamic fee system. We introduced the byte-based block size. Initially, up till Lisk 3.0, we were running the node with number of transactions per block. But with Lisk SDK 4.0, you can define the block size in the term of bytes, and then the whole chain will grow accordingly. And we introduced the new multi-signature architecture, and we also remove the timestamp and introduce the nonce that can help you to avoid the double spending attack. And we also introduced the vote locking period so that people can put their stake into the network, and then they should contribute productively and make the network more secure. And with that 4.0, we introduced a new feature which was like a long awaited. We introduced the standby delegates. So not only the delegates which are forging in the network, now the delegates which are not forging and they are just contributing to the network, they will also be incentivized with this Lisk 4.0. And in Lisk 5.0, we have more features. We introduced the transaction ID system, new block ID system. We also introduced a generic serialization method, which can help us to convert the data into binary format back and forth without any problem. And then we introduced the numerical trees to include the proofs. And then there is a lot of different Genesis block and snapshot and hard fork processes introduced. And most importantly, for a developer perspective, we have introduced embedded databases in Lisk SDK 5.0. And before that, we were using PostgreSQL, and we observed that some of the community members were not been happily using Postgres. They were having a trouble in setting up. So why we remove the Postgres dependency, and we can completely go to the embedded databases. And we also removed the dependency of the undo step that you had to define for your state transition. Now you don't. We will calculate the state transition automatically, and if required, we can do undo automatically. And in this version, SDK 5.0, we introduced an on-chain architecture. And this on-chain architecture is the one which gives you the most flexibility to create any kind of a use cases or develop any kind of a use cases on Lisk SDK 5.0. And with all these features that I just highlighted to you guys, these total are around 850 issues, 790 pull requests, and 30 plus libs that we have covered. And all these things we have covered in the 1 year time frame. It's a pretty short time frame to cover all these things, but we have made it possible even during the epidemic. And that's all for theoretical stuff and explanations. Let's go more deep towards the technical foundation of the Lisk SDK, which is our Lisk SDK architecture. I can easily and more abruptly can divide or can specify 3 traits which we focused in our mind to build these architectures. And the Lisk architecture itself have like a basis on these 3 action points, which are the flexible, integratable, and open. And for each individual trait, we focus particularly on that trait, and we develop a particular architecture for that. So for a flexibility perspective, Lisk on-chain architecture gives you all the flexibility that you need to build any use case in the blockchain. And then blockchain is a bit complex stuff. You need to integrate the blockchain into some other system. That's a pretty much everyday use case. So for that particular aspect, we have introduced the Lisk off-chain architecture, and that can help you to build the integrations for the external tools that are connecting to the blockchain. And then we have another aspect which was that some people may have different technologies or different tools that they are using. So we developed Lisk communication architecture, which is open. It does not have a dependency of the JavaScript. If you are a PHP developer or if you are a Python developer, you can still use the Lisk communication architecture to communicate with the blockchain application openly. So these are the 3 traits, and now I can dive deep into the Lisk on-chain architecture, which is quite interesting. So remember that this Lisk on-chain architecture is the one which will give you all the flexibility you need to build any of the use cases. And in a Lisk on-chain architecture, the main aspect or the thing that you are going to design is the Lisk module. So everything you design is called a Lisk module in the on-chain architecture. The Lisk module will bound it to the application that you are building. And Lisk module has 3 major points. One is the data structure, one is the control, and one is the interfaces. So it gives you the flexibility of defining the data structure that you want to use, whether it is the account schema or whether it is a transaction asset schema. You have the full flexibility of defining any kind of a data structure. These data structures are isolated, they are unique, they are readable. So if you define any account schema, that account state or schema will be isolated to any other module, and that will automatically be serializable to the binary format. And this binary serialization is be done with the help of JSON schema and protobuf. So we have developed our own encoding scheme, which is based on protobuf, but the interface that it defines is based on the JSON schema. So anyone is aware of JSON schema, which most of you guys should be. So you can use the JSON schema and then serialize data back and forth to the binary and JSON format. And then we have the control over it. Then once you have the data structure defined, then you want to control it. Then we provide the lifecycle hooks of the blockchain application, whether it is a block, whether it is a transaction or something else. You have a full control of all these things. These controls are all granular. You can go up to the transaction, individual transaction level, or you can say up to a higher level on the Genesis block or the block. These are isolated, these are fail safe. You don't need to worry about anything. If something goes wrong, it will be reverted automatically. And then we have you need to define the interface. So once you define a module, that module may or may not want to interact with other modules or complete some kind of a business requirement, then in that case you have to define the interfaces. And there are three types of the interfaces that you can define. One is the reducers, actions and events, and I can go into more details to those in the hands-on demo. And these are the list of default modules that we can publish within the SDK. One is the token module, which is responsible of handling all the balance related transactions, whether it's a transfer transaction, so it's handled by the token module. Then we have a sequence module, which is handling the account nonce, which can help you to protect the double spending attack. Then is the keys module, which is responsible for verifying the signature of the transactions or verifying the multi-signature accounts. Everything has been handled by key module. And when we have the DPoS module, which is had a core responsibility of managing the consensus related to the DPoS. These are the four default modules that comes along the SDK. You don't need to install them. They will be pretty much configured and available to you. And then we have this off-chain architecture, which I earlier talked that this is integratable. So sometimes you need to process something which is not related to the blockchain, which is not related to the transaction, which is not related to the block, but it is still some kind of a processing, which we tend to call an off-chain processing. So this for particular off-chain processing, you can use our Lisk off-chain architecture. You can create a plugin. You can have put any kind of an independent logic into that plugin, and that plugin can interact with the application and provide actions and events which can be used elsewhere. So this way the application will stay isolated, and your application, your plugin can still run an independent business logic. And there is a flexibility that if you want to run that particular plugin in the same process, or you want to run this plugin in a child process to use the maximum performance of the hardware, so it's up to you. That is also possible. But to remember that this is an off-chain structure. You don't need to process any blockchain related data or any blockchain related processing in the Lisk plugins. So for blockchain, you go to the on-chain architecture and define the modules. So once you have the plugins, then we have this these two plugins that we expose from our SDK. One is the HTTP API plugin, and then we have this Forger plugin. These two are very pretty basic plugins that are available, but they can provide you all the features that you need to cover up the requirement of any simple blockchain use case. And then we have this open Lisk communication architecture, which is based on the IPC Unix sockets. Whatever blockchain application you build, it will expose an IPC Unix socket where any JavaScript or any tool in the Rust or any Python or any other language can interact with the IPC socket. and they can call the actions, or they can listen to the events within the application, and then they can do any kind of off-chain processing according to it. And with that said, this is all pretty much, and with these three particular things, Lisk on-chain architecture, Lisk off-chain architecture, and Lisk communication architecture, you can build any kind of a use case that you want without any problem. And for a bird eye view, I will say that this is the whole application that you will be building or you will be looking into. Lisk application is composed of these layers. One is the node layer, one is the modules layer, and then the plugins. Node layers consist of forging logic, network logic, block processing logic, and synchronizer. And then for the token modules, we have tokens, sequence, keys, and depots. And there is a space for you to create your own modules afterwards, and you can plug them in. And for the plugins, you can create, we provide HTTP API plugin and the Forger plugin. And same as you can create your own plugins and plug into the application. But the whole layer will be called an application. And afterwards, we have this Lisk communication architecture where you can connect external tools like we have Lisk Commander or we have Lisk Core CLI, and you can build your own tool in any other language or any other platform, and you can link them with your application using the Lisk communication architecture. So this was all of the bird eye view on technical aspect of the Lisk architecture. And with that said, I was like talking a lot about the use cases that you can build. And yes, there are pretty much a lot of use cases that you can build. So let me highlight some of those. So this is a research paper from Credit Suisse Research, and they categorize the different use cases of a blockchain into three major categories. One is the disintermediation of the trust, one is the immutability, and then is the smart contract. And within these categories, you can see different sectors which can cover up here. And I would say that based on the Lisk SDK, you can pretty much do anything possible in these green and the blue circles. Either is the disintermediation of the trust, either it is an immutability. You can do anything related to health records, art registered, crowdfunding, fintech, whatever use case you want to build, you can do it easily. Related to the smart contracts, Lisk SDK does not provide any built-in or ready-to-use feature for creating smart contracts, but there is possibility that you can still create a platform using the Lisk SDK that can provide the smart contracts, but that topic is not part of today's session. So you can pretty much focus right now on any of the above these of the use cases that you want to build, and with these use cases we can also build a hand-on demo. I prepared something for you that I can show you how easy it is to build a blockchain application using Lisk. And one is we will be preparing a non-fungible token for it. A non-fungible token, if anyone of you don't know, so non-fungible token is a digital token which is unique, which is immutably interchangeable, and which is indivisible. So you guys can explore more details of NFT further, but I can like summarize you that unique is mean that it is something unique which owned by someone which cannot be existing elsewhere, and it is not mutually interchangeable. For like a normal token which is interchangeable. For example, you have one Bitcoin, you give it to someone, and you get one Bitcoin from someone else. So it doesn't matter to you. It's the same thing that you have one Bitcoin. But for an NFT, it is not mutually interchangeable. Something you have is the unique, and it cannot be replaced by some other token. And same as you have the NFT tokens are indivisible. They can be they cannot be divided into the chunks or been segregated into different parts. Like Bitcoin, you have one Bitcoin, you transfer one half Bitcoin to someone else. This is not possible in an NFT token. they are not and never been indivisible. So there are different use cases that you can build using an NFT token. One is the crypto collectibles, which is the most famous one, and which is available. And one which is people are crazy about is like crypto kitties. And then a digital artwork can be implemented in an NFT token. Event system or a non-fungible event can be, whether it is an event to a concert, whether it is an event to an airline, like ticket to the airline. So anything you can build with a ticket system with the NFT. And an NFT can be built to create an item in the universe. A virtual universe can be a game or any other thing, any fantasy. So you can represent any NFT token associated to any item in a virtual machine. And NFT also can be used as an identity, because identity has all those features that it is unique, and it is indivisible, non-transferable. So you can use NFT token to build a digital identity solution as well. And the good thing is that we will be building an NFT token today, which will be pretty much all that you need, and then you can add more details related to a particular use case in that NFT token, and it's a ready-to-go solution. So what is our non-fungible token? And so our non-fungible token will be a blockchain application which will have a support of an NFT token, and that NFT token should have an initial value, and it should be purchasable with specifying an auto purchase margin. So if you specify a purchase margin, that let's say my token has an initial value of 100 and it has a purchase margin of 20, that means anyone can purchase the token automatically more than 120 token value. And then it should have, the NFT token should have only one owner at a time. So it cannot be divided among two people. And if you set the purchase margins to 0, then they will become non-purchasable. And if you have a money, you can create any non-fungible token. And if you have a token, then you can transfer it to your own token to anyone without specifying or fulfilling the profit margin requirement. And anyone can change the like purchase the NFT token. And the last part of this use case is that those NFT tokens should not just be inside the blockchain, and they must also be accessible from the outside of the blockchain, so we can build any other tool or use those tokens in a different use cases. So this is pretty much all of our use case that we want to build. And if I segregate these concepts into different categories or terms that we use commonly in a blockchain, and particularly in the Lisk SDK ecosystem. So this is pretty much all. The whole thing that we want to build is a blockchain application. And in the blockchain application, this NFT token is a particular behavior of the blockchain that we want to build. So this is a module. And this last part is the one which is say accessible. Uh, so you can see that it's a non-fungible token should be accessible to the outside. So this accessibility feature is something which is not been intended for the blockchain itself. So we will build it as a plugin. It will work with our application, but it will not have any kind of a dependency on the blockchain itself. And then within the module, if I say that token has an initial value, token has a purchase margin, and token have an honor, these are all of the account states or the token states that we want to save inside the blockchain. And then in the yellow section, we have different kind of behaviors that we want on top of the NFT token. One is that someone can purchase it, someone can transfer it, someone can make it non-purchasable. So these all are the behaviors, and in the behavior term, we call them the transaction. So apparently, if I look on this diagram, so first thing we need to build is an application, and within an application, we need to build a module and a plugin. And then within a module, I can see there is some account schema that we need to define, or the state schema that we need to define. And then we have these transactions, 1, 2, and 3. 3 transactions that we need to define to fulfill these 3 behaviors, and then we will have a functional blockchain. So with that said, now it's the time for doing it practically, and let's do it. So all in one, you need just one package to build this, which is the Lisk SDK package. You can install it, the latest version of the SDK from our own registry. Since I'm doing this demo with the latest SDK 5.0, so you have to use it from our own registry. It's not yet published to the NPM, public NPM, but we will be publishing it to public NPM soon. But it's open public, and you can use our registry without any problem. So you just need to install the Lisk SDK at latest. Say, I am in the demo, and let's say I start with it, and so I did all these things, and I have a pretty much simple package JSON file which have the Lisk SDK and which was installed using the tool that I just command I just shared. So let's create our first file and say index.js, and we want to build. Hope you guys are seeing it clearly. The code is being shared and visible to everyone. So we need to require a Lisk SDK package, and the most important thing that here we need to require is the application. And then we need to require something else, but I can go afterwards. So we need to build our first application. There are some things that you need to define. We have a pretty much configured application available that is called the default application. So that can avoid you to create to define some application without the default modules. If you call using the default application, then you will get an application which will be pre-configured with the default modules. But if you don't want the default modules, then you can use the constructor to use it. So the default application need two things that are the Genesis block and the configuration. And for particular part, you can use the configuration from the package itself. You can use the Genesis block from the package itself, and then you can pass the Genesis block and the config here. So this is the pretty much anything that you have to do, but for the sake of the demo, I'm not using these configurations. So I am using my own configuration file that I have, and I'm using my own Genesis block, which I have. But if you want to explore, you can simply use the Genesis configuration that is being exposed using the package itself. So I'm going to use these configuration that I have, and then I pass the configuration, and then we have pretty much everything configured. Our application is ready to start. We just need to call it start, and this, let's put some message here so you can see if application is started or not, and in case of some error, you can also want to see the errors. So we have all, and if you guys can see, these are all just 1 or 2 lines of the code that without the package dependency, that you can simply start a blockchain application. And now if I want to start this blockchain application, I just need to start it and it will be working. So we have to clean this up something. I can figure this out later, and we can start. So I did clean up a bit of a cache that I had earlier, which was causing a problem. So with these simple lines of code, and I was able to start a blockchain application. You can see that it started forging, and the default block time is 10 seconds. So you will see that after every 10 seconds, a new block is being forged. Let's wait for another block. So we have block 4, and it's growing and it's growing. So this is pretty much all that any blockchain need, and it is been predefined and pre-configured with the with what we have already, the default modules. So you don't need anything else. Now we go towards the other part that I was referring, that we need to build a module. So we need to build a module, and that module can be called here, and like base, you need to include a base module class, and then you need to create a module here, and the module extends base module. So this is a module you will get. Then you have to specify an ID and name of the module, and this is the ID. Let's say we can say name is equal to NFT, and we can say ID equal to 1000. And why 1000? Because it's a custom module. First 999 are like restricted for within the default modules domain, so you can not use it. And then afterwards we just need to register a module with the particular application. And Mora, you have a running module that have an NFT, and it has been configured and it's been ready to use. But since I can now go to the further details of the code, and we can show you directly into the code, because we don't have so much time. So hope you guys can see the code clearly. So here was like we were at the time. So we have this NFT module, which have these base modules extended from the base module, and this is the account schema of the base module. And we are modifying the current account or the default account, and we are specifying that now account will have a new properties, which is an own NFTs properties. This property will be an array of the IDs of the NFT tokens that an account will own, because account can have an NFT token can have only one owner at a time. So there will be a cross reference of the owner. So the token will know about the owner, and the owner will have a reference of the NFT token. So this is all that you need to define in a module. And if you focus here, we specify the transaction assets, that these are the transaction assets, because there were three transaction assets that we want to perform. One is the create NFT, one is the transfer NFT, and then is the purchase. And for that particular part, I can go into the transaction assets, and I can explain you guys with this NFT asset token. So create NFT is again a simple class which is extended from the base asset. Then you can name it, you can specify an ID for it, you can specify a schema for it. This is a base JSON schema which you use in the module as well. And here we define that to create a token, you need to have a minimum purchase margin, and you need to set an initial value. And if you specify these two attributes in a transaction, then we can create a token, NFT token for you. And here is the apply logic for it, that you will get an asset state store. State store represents the in-memory store for the current block which is under processing. And then you know the transaction which was being processed. And at the time we simply do some logic. We call from the account state about the account, and we get the minimum balance of the account. And here are some checks that we need to perform, that if the initial value is minimum, then the remaining balance. So user should have the enough balance in the account, so he can create an NFT token. And here we created an NFT token. I will explore this later. Once you have an NFT token for the owner address for a given transaction nonce and for a given initial value, we set this token ID into the owners, and then we updated the account for this particular sender address. And we did not forget to debit the balance of that sender, because he just created a token, so his balance will be debited afterwards. And then we save those tokens into the state store as well. So same is for the purchase. If you want to purchase an NFT token, you need to specify an NFT ID, you need to specify a purchase value of it, and then afterwards you need to apply this transaction. And when you are processing a transaction, So you need to first check that the token ID that is being represented as an NFT ID is valid, and then you need to specify uh, which purchase value you want to purchase. So if everything goes well, then this is the purchase value that say the minimum purchase value which was valid for this particular token, and if that is valid, then we simply remove that token from the token owner, and then we put that token into the owner like current purchaser's account, and we also change the value and the owner of the token itself, and we debited the account of the purchaser and we credit the account of the token owner. So this way one person has the given the tokens to the other one, and in the sale, in the purchase of the particular token. So this is all, and since we don't have enough time to go into further details, there is only one thing I can show you, and then I will go towards the UI side of it. So this is the logic for creating a token I used, and this is owner address, nonce, value, and minimum purchase volume. And we use the cryptographical hash to generate a unique ID. And since owner address is always unique and the nonce is always unique, so we use this as a seed to create the ID of the token that will always be unique and identifiable. And then we use our codec that we are available in our SDK, and we use it to encode data into binary and saved it, and same for getting the tokens. So this is at all, and now I want to show you guys with the demo. Let's start our backend application. So NFT blockchain application I want to start. So it started, it's running, and I have built a sample front-end application for UI as well. So you can use it for looking or interacting with the blockchain. And for this particular part, since our blockchain application cannot interact with any React app, so we need to build a plugin as well. So I created another plugin. You see here we have this NFT API plugin, which is been extended from the base plugin that we have. And this plugin is just creating an Express server, and then Express server has different endpoints that will give us the data. And to get this data, it's using the channel concept that we have, Lisk communication architecture, and it's just getting the NFT token. And this get all NFT tokens are being defined inside the module that we simply have it here. So it's defined in here. So you have a plugin which is just serving an HTTP server because it's not a blockchain aspect or is not some online processing. So you have to do it. And now we start the front end. So we have a running application now, and it will take a few minutes to show this demo. So first thing is that you need different accounts that you can purchase some tokens, or you can like have those tokens. So you have want to create an account. This is just generating a random passphrase and a random address for you. You just need to copy it and keep it somewhere. And I need another account as well, so I copy it and I keep it somewhere else as well. And then we make some transfer to the funds. So I say that transfer these address, let's say 1,000 euros with the fee of 1, and the passphrase, we can use the Genesis account, which has a lot of passphrases to fund these accounts, because these are the new accounts. Let's submit this transaction. So we have some problem in here. Always face. So, and without going to the demo, I can go to the code as well, then and explain this to you. So in the front-end app that we have, this is the logic that you can use to create and send the transactions. And in the yeah, in the transactions, here is the logic that is like responsible for creating those transactions. So the initial thing is that we need, first of all, we need the schema, and this is the schema that we had, like the attributes of the transaction. And within the transaction attribute, we have this module ID and asset ID. If you guys remember, we created these module ID, and inside the transaction module, I specifies the ID 1000. So I have to use the 1000 module ID here. And then I have this NFT ID one, create NFT asset ID one. So this is the asset ID one, and this once we create with the asset ID, we need to specify the nonce of the account. We need to specify the fee of the particular account and particular transaction. And then we have the sender public key that we get from the passphrase. So you guys remember I got some passphrases on the interfaces. So from the passphrase, we use this get address from the passphrase, and everything afterwards we use this public key, and then we use the passphrase to sign the transaction. And once you sign the transaction, you have this transaction object, and then you can send this transaction object to the server which is serving the API. And I can show you some utilities in the API, which is quite simple, and which simply sending the transaction to an endpoint, and this endpoint is being exposed from our HTTP API. And for the HTTP API, I can give you an example here that you simply need to import an HTTP API plugin from the SDK, and you need to register the plugin, and that's all that you need. And right now we have two different plugins. So two different plugins are serving two different stuff on the server, and then you can call those endpoints. And this is pretty much all you need to create and run an application. And this application will be available for you on our Lisk SDK examples repo, when you can explore it and you can go with the further details, or post command or improve it from there. And I'm gonna take a few more slides here. And so we developed a minimal blockchain application, which I showed you guys is running and without any configuration or something, with few lines of code. And then we develop a custom module. And within the custom module, we also develop a custom plugin to serve the data on a HTTP server. And this is all I have for today. And you can explore us further on our GitHub repo. There is a Discord channel. We have Lisk chat. You can go there and connect with the community. And we have dev.lisk.io portal, which you can go to ask any of a question. And if you want to explore more details, we also have the Lips portal, where we publish our improvement proposal, which is quite a lot and a lot of technical. So you want to explore it. And if you have any technical question, you can ask us on the dev portal as well. And that's all I have.